Good day, everyone. Our lesson for today is all about the teaching of mathematics. But before that, don't forget to like and subscribe to this channel and hit the notification below for more updates. The nature of mathematics. Math is definite, logical, and objective. The rules for determining the truth or falsity of a statement are accepted by all. If there are disagreements, it can readily be tested. It is in contrast with the subjective characteristics of other subjects like literature, social studies, and the arts. Math deals with solving problems. Such problems are similar to all other problems anyone is confronted with. It consists of defining the problem, entertaining a tentative guess on the solution, testing the guess, and arriving at a solution. There are strategies in mathematics. Strategy for teaching mathematics depends on the objective or goals of the learning process. In general, these goals are classified into three: the knowledge and skill goals, understanding goals, and problem solving goals. Let's start with the knowledge and skill goals. Knowledge and basic skills compose a large part of learning in mathematics. Students may be required to memorize facts or to become proficient in using algorithms. Example of facts: 2 times 10 equals 20, or the area of the rectangle is base times height. Example of skills: we have multiplying two digits whole number, changing a number to scientific notation. So those are skills, and the example of facts is more on knowledge or content. Knowledge and skill goals require automatic responses which could be achieved through repetition and practice. Understanding goal is the distinguishing characteristics of understanding goal is that understanding must be applied, derived, or used to deduce a consequence. Some strategies used in understanding goals are the following: authority teaching, interaction and discussion, discovery, laboratory, teacher-controlled presentation. When we are talking about authority teaching, the teacher as an authority simply states the concept to be learned. The techniques used are by telling which is defined, stating as understanding without justification, by analogy, and by demonstration. When we are talking about interaction and discussion, interaction is created by asking questions in order to provide means for active instead of passive participation. Letter C. Discovery. The elements of a discovery experience are motivation, a primitive process, an environment for discovery, an opportunity to make conjectures, and a provision for applying the generalization. Laboratory. The advantages are: maximize students' participation, provide the appropriate level of difficulty, offers novel approaches, improves attitudes towards mathematics. This is done through experimental activities dealing with concrete situations such as drawing, weighing, averaging, and estimating. Recording, analyzing, and checking data enables students to develop new concepts and understanding effectively. And last is teacher-controlled presentations. The teacher uses educational technologies such as films and film trips, programs, materials, and audio materials. Other activities are listening to the source persons and conducting field trips. Suitable places for educational trips are government agencies such as the Weather Bureau, Post Office, and community supermarkets, factories, and transportation centers like the bus, depot, and airport. Another goal is the problem-solving goals. The problem-solving is regarded by mathematics educators and specialists as a basic mathematical activity. Other mathematical activities such as mathematical generalization, abstraction, and concept building are based on problem solving. Others believe that a more important role of problem solving in the school curriculum is to motivate all students, not only those who have a special interest in mathematics and special attitude for it. There are strategies in teaching maths. We have problem solving, concept attainment strategy, concept formation strategy. Problem solving, as defined, is a theoretical basis for problem solving strategy like constructivism and cognitive theory. Constructivism, this is based on Brunner's theoretical framework that learning is an active process in which learners construct new ideas or concepts based upon their current or past knowledge to create meaningful learning. Cognitive theory. The cognitive theory encourages students' creativity with the implementation of technologies such as computer, which are used to create practice situations. Guided discovery learning. Tools engages students in a series of higher order thinking skills to solve problems. And metacognition theory. The field of metacognition process holds that students should develop and explore the problem, extend solution, process, and develop self-reflection. Problem solving must challenge students to think. Cooperative learning. The purpose of cooperative learning is to make each member a stronger individual in his or her own right. Individual accountability in the is a key to ensuring that all group members are strengthened by learning cooperatively. Teachers need to assess how much work each member is contributing to the group's work, provide feedback to the groups and individual students, help groups avoid redundant efforts by members, and make sure that every member is responsible for the final outcome. The favorable outcomes in the use of cooperative learning is that students are taught cooperative skills such as forming groups, working as a group, problem solving as a group, and managing differences. So these are the different theories or strategies in problem solving. Again, we have these three teaching strategies in teaching math. We have problem solving, concept attainment strategy, and concept formation. For the problem solving, we have 5: constructivism, cognitive theory, guided discovery learning, metacognition, cooperative learning. Now we have these steps for the problem solving strategy. Restate the problem. That's the first one. Second, select appropriate notation. It can help them recognize a solution. Prepare a drawing figure or graph. This can help understand and visualize the problem. Identify the wanted, given, and needed information. Determine the operation to be used. Estimate the answer. Knowing what the student should get as the answer to the problem will lead the student to the correct operation to use and the proper solution. Solve the problem. The student is now ready to work on the problem. Check the solution. Find a way to verify the solution in order to experience the process of actually solving the problem. Other techniques in problem solving are: 1. Obtain the answer by trial and error. It requires a student to make series of calculations. In each calculation, an estimate of some unknown quantity is used to compute the value of the known quantity. Use an aid model or sketch. A problem could be understood by drawing a sketch, folding a piece of paper, cutting a piece of string, and making use of some simple aid. Using an aid could make the situation real for them. Search for the pattern. This strategy requires the student to examine sequences of numbers or geometric objects in search for of some rule that will allow them to extend the sequences indefinitely. Example: find the 10th term in a sequence that begins in 1, 2, 3, 5, 8, and 13. This approach is an aspect of inductive thinking, figuring a rule from examples. Eliminating strategy. This strategy requires students to use logic to reduce the potential list of answers to the minimum. Through logic, they throw away some potential estimates as unreasonable and focus on the reasonable estimates. Concept attainment strategy is another way or strategy in mathematics teaching. This strategy allows the students to discover the essential attributes of concept. It can enhance the student's skill in A. Separating important from unimportant information, B. Searching for patterns and making generalization, and C. Defining and explaining concepts. Steps: select a concept and identify its essential attributes. B. Present examples and non-examples of the concept. C. Let students identify or define the concept based on its essential attributes. Ask students to generate additional examples. Effective use of concept attainment strategy. The use of the concept attainment strategy is successful when students are able to identify the essential attributes of a concept. Students are able to generate their own examples, and students are able to describe the process they use to find the essential attributes of the concepts. Concept formation strategy is the last strategies that you can use in teaching mathematics. This strategy is used when you want the students to make connection between and among essential elements of the concepts. So steps, we have A. Present a particular questions or problem. B. Ask the students to generate data relevant to the questions or problem. C. Allow students to group data with similar attributes. D. Ask students to label each group of data with similar attributes. And E. Have students explore the relationships between and among the groups. They may group the data in various ways, and some groups may be subsumed in other groups based on their attributes. So that's all about the teaching of mathematics. Thank you for your listening. Don't forget to like and subscribe to this channel and hit the notification buttons for more updates. Bye.